Welcome to Turn Right Machine Works. My name is Keith, and today we have a little project, and this is just a little component, a little part, but it's gonna need a little bit of creating some tooling for it, and we're gonna have to do a little trick on it so that we can make what they want a little easier and a little truer than need to be. Now you first say, you know, the title of the video and everything else. Well, we're talking about a clapper on a bell. And most people that don't know what it's called would call it a knocker. And so that was the punning on the video title there. So anyway, on our clacker, the part that they're missing is the little pull ring that needs to be attached to a rope, and then they can ring the bell by a direct pull on the clapper. Alright, and anyway, this ring is going to be 3/8 diameter material, and we're going to bend it into a D-shaped ring. About 2.5 inch ID is, you know, that'll give it a little bit of play on each side of the clapper. And then we're going to make a pin that will go through 2 ears. Normally they would bend this around, forge it, and I'm going to do a little trick to where we got the appearance of the forged ears, but we're not going to have to go through the painstaking forging and circling that thing around, especially when we're working with a piece of stainless steel. And we're going to be doing almost everything cold except for a welding process that I will join what is going to appear to be a forged to the ring, and then we'll blend it all in with a little Scotch-Brite pad and kind of forge out something or look like something is forged out of the stainless ring here. Alright, so first off, I got the 3/8 material, and then we got a piece of 1.25 inch, and this will create our 2 dummy rings that will appear to be a forged loop on each end of the ring here. Now, we're going to be using a tool that I made myself, and very similar to a Hausfield bender. And it's basically a round disc with a couple standoffs here and a bar up here with a hole pattern that matches the lower hole pattern, almost like the 2 arms on a Hausfield bender. And I created 2 flathead bores here so that I could go ahead and put 2 T-nuts right into the tabletop here and tighten this right down to my mill table. That gives me a nice sturdy platform to control or hold my base of my bender. And time to time, you know, you do want to have it sitting at the right position so the mill, you know, I turn it on and I rapid traverse it around where I want, and I might move it a little bit, but right now it might be in the right position. Anyway, I'll go ahead and tighten this up, and then we're going to go ahead and get the arm. Now the arm is basically, looks almost like the Hausfield arm as well, and I just basically machined 2 sets of standoffs there and a series of holes in here so that I can control the secondary pin in the rotation of the swing as need be. And then this one pin right here is a matching pinhole that creates the center pin. Alright, I'm going to go ahead and get my my unit bolted down to the table, and then we'll come back and we will have to make a die or a dummy ring to pull that stainless around to be the diameter that we want to create our D ring out of. Alright, so let me get this tightened down here. I used to have 2 Allens here, and I used an Allen for a job there the other day, and so I had to use a screwdriver slot here, but either way it doesn't matter. And it doesn't take much to hold this thing down. And the weight of this machine gives you way more than enough weight and support to go ahead and pull on most of the things that I work on in this. This is a great way to mount something that you use only once in a while, and you're storing the rest of the time. Otherwise, you know, most Hausfields and stuff like that are mounted right on a post in a concrete floor, and then you have that area all the way around you. And this kind of gives me the opportunity to mount it here, over there, and put it on another machine, whatever it, you know. But it really does work real comfortable right here in my shop. And it's one of the first things that I made when I left an area where I had a hospital bender at my disposal, and I use it all the time. You know, whenever you do have a tool that's available to you, you use it more than you would if you had to go borrow it, or and of course if you didn't have one, you can't use it. Alright, so we're set up here. Now what we need is, and by the drawing, and basically my drawing is very, very simple. Just basically a 2.5 inch ID, a 3 inch depth, a 3/8 pin crosswise. Alright, so it's kind of a big drawing, but it gives me all the dimensions. So what we're going to do is we're going to go for the 2.5 inch diameter swing there. And somewhere around here, I put a piece of material to go ahead and make this project with. Alright, we found a piece, and this was just a round disc that was cut off, and I had it over there on the hydraulic press. We use it over there once in a while, and it's just a diameter that I'm able to put down and use with my hydraulic press. And it has a hole in it already. I think it's just clearance on the 1/2 inch, but we're going to go ahead, and we need to make it so that it'll slip over the 1 inch and we can use it here. And then once we got this down here, we have a drop pin that's in over here, and we can switch that for holding the rod on the outside, and we'll check out what's needed there. Then we have another drop pin, and we drop that in here, and this is usually for a roller or something on the outside here to push on the outside of the material. Sometimes we just use a straight drop pin in close. We don't know until we actually put this in there and stick our 3/8 rod in there, and we'll find out what we got for clearances. Our first thing is, let's go to the lathe, and we're going to go ahead and put a 1 inch hole in the center of this disc here. Sometimes when you're putting something in a 3 jaw, if you give it a slight rotation as you're tightening on it, it will self-align itself with the bore or the spindle of the jaw. And sometimes you get it to where it's okay? And that was a bad example. But we'll try it again. There you go. Bringing the carriage up, all we're going to need is our tailstock here, and we're going to go ahead and we're going to drill it out to 63/64 and then run our 1 inch reamer through there. Alright, and we're going to go ahead and slow her down here. check our fit. Alright, we went ahead and just quickly deburred that with a large countersink, and we did slide it over so we know it fits our 1-inch diameter pin here in the middle. What we're going to do is we're going to set this here, and we're just reinserting. When this pin is in location all the way down, that goes all the way down to the table of the mill, and it just rests there. There's nothing that holds it in there, but it aligns the arm, the bottom plate, 2 forks right here, and holds your diameter. Alright, now this pin here picks the location, and this pin's a little bit bent from force, and we pick and choose different positions to put this in and out. It looks like it, and I'm hoping that that pin in the first section there allows this to fit through there, and it doesn't. Alright, what we're going to do, we're going to measure that width right there, and we're going to see how much, and I think I'm going to skim off the Odia here. We're going to have a little bit of spring, even though this measures 2.5-inch diameter, and our ring is going to bend in 2.5-inch diameter. I know that from experience that you'll bend something around here, and then when you relax it, it becomes just slightly larger. In fact, we might actually have to hold this in a position and heat it to get it to relax in the 2.5-inch diameter for the inside. The clacker or knocker diameter is 2-inch, and we're supposed to make sure that it has plenty of play and slop, and there's no restrictions on it at all. So let's go ahead, and we're going to measure that gap right now, and I may be able to get in there with a pair of dials here. Let's see. Yeah, it looks like it. Alright, so I got like 325. So if we took 25 thousandths off of that, we'd get it out to like 375, and that would be equal to the diameter of our rod. Alright, this is 3/8 rod. Alright, pull this out. We're going to friction drive this in a lathe and put this in here just so we don't lose our handle. We're going to put the live center in here with a flat plate here, and we'll just friction drive it and take a skim on the OD, and then we'll be able to come back. That way we don't have to actually move this back and make another type of spacer, and it gives us full contact with minimum amount of play to insert that 3/8 rod and start our bend. Alright, we'll take care of that, and then we're going to come back and then we'll start with the pin and the pull around part of the puller or bender here. Alright, I went over and found, and I keep this over with my hydraulic press where I might be pressing things in the hydraulic press. Bearings, sleeves, whatever. This slug here has got a bore, but it's got several different shoulders and things like that turned on it, and I kind of like keep it around. It comes in handy for a lot of things. Friction driving, by having a couple different shoulders here, gives you a couple options of actually holding things and pushing them against the part itself with the live center to hold the part so that you can skim cut an OD and hold it fairly true to the ID without too much effort or work. So what I'm going to do is put this in the 3-jaw, and I'm chucking it good and snug. This is against the jaw, so it can't move in any farther, and it can handle push on it without pushing it into the chuck, and you don't really have to bear down and really clamp your jaws real tight. Alright, now we're going to be running this against here and then with the live center. But we want to take a look at this face here. I don't know what condition it is. We want to make sure that it's not running out, because we want something at least smooth and flat and running concentric. And it's a little bit slow. It is running pretty true, but it's not a very big surface to play with, so we're just going to go ahead and actually my tool block here is 90 degrees off of where I normally run it. I can just tell by my handle here it's not in the position I like. Okay. Now we're just going to touch here. Take a light skim. So we know that that surface is running true. Now we can go ahead and put this against here, bring in our live center. And here again, your distance, sometimes that you reach out with your center, you like to keep that down to a minimum so you're not losing any of the rigidity of your spindle. With it hanging way out, you're not gonna have as much support with it. So what I do is I set that up usually, and then I adjust the carriage so that I can get my cut, my swing, my tool bit, and all of that. Sort of a medium force with the tailstock. Grabbing your center or grabbing your part, of course, you know, I don't want to get cut, so this is nice and smooth and I can grab it with my hand. I'm just kind of making sure that it's not going to free spin and it has pressure against it, it's going to create the turn. You may have to add more if you don't have a good bite. That's why I usually facing the backside, getting a good support with your center here and an adequate amount of pressure. You might have to minimize on what you would take as far as cut wise, whereas if you had the part really chucked in the chuck and you were holding it in the 3 jaws or 4 jaw, you would be able to take more meat. But this is, we're just taking bare minimum to get this down 50 thousandths to the size we need for our clearance on our rod there. Now, because my clearance back here is up against the tail, I don't want to go right up against there and limit all my room. So I'm just giving myself a little bit of room to be able to get out of the way here and put this in a nice position to get to my surface I want to cut. Touch off. Now you can use regular feed. In fact, I will. I'll put it in some of my average course feed right now, about 10 thousandths per revolution, something like that. I know I have to take 25 aside, so here's 20. Now we can take a dimension on this here. Yeah, 2450 or actually 2447 or so. So we've got like 26 and a half or so thousandths per side clearance. So it should fit in there, and our 3/8 rod should definitely make it in there also. What I like to do now is, because before I actually pull this out, just to break this edge and this edge here, sort of DNMP, and I have 2 of them set up here. I use them for a lot of different turnings, but I also use the backside as a quick chamfer tool. So now both edges are I just break them so they're not sharp. Alright, now let's go check our fit. Alright, now we'll go ahead, put our piece back in here. We're going to check our there we go. Check our fit. And somehow we're still too tight. Maybe we were just raised up there. There we go. Okay, this pin was, like I said, this pin was bent. Alright. So we're slipped in there now. Now we need to go ahead and create the pull around. Alright, now this hole here is blocked by our piece there. So we're going to be dropping a pin in back here. And of course it's a little bit far back here. We want to get in a little closer. So I'm going to go ahead and create another ring that will take up some of that play in here. Now I have a couple already made up, and I think this roller right here may be just enough. There we go. That's going to take care of enough. That'll get us there a little bit quicker. All right. Now we're going to leave a little bit or tail out here so we have something to work with, and we're just going to want to bend around and create a D-ring. And we just pull this around. And you can see when I let go, it has a little spring, and you can see the gap back on this side here. When I release it, you can see that gap coming right there. Alright, hold this back down. Alright, now we're going to want to pull it till we got, this should be 2.5 inches, and we'll measure that with our scale in here. When we relax it, it comes back to 2 7/8, and we add a little bit more. And it's like 2 5/8, but it's sprung open about 1/8 of an inch here. Alright, so what we're going to do is we're going to go ahead and get our torch set up, and we're going to go ahead and hold this into that position, and we're going to put some heat around here, and we're going to relax that ring right to the 2.5 inch inside diameter, plus or minus a little bit. We're not held to this. I mean, you know, this is just pulling on a knocker. All right, just a second ago I was staring and getting ready to go ahead and get a clamp, and thinking about bringing this around, measuring, hold this in a position, and I noticed how close this pinhole is here. So what I did is I brought this back like this, and I pulled this roller out, dropped the pin in to the closest hole there. Now it has almost zero room there to have any flex or move away. Now this is 1/2 inch bar here, so I got to get a piece of 1/2 inch to lay in here, and I happen to have a piece or two over here. Alright, just so we're holding everything horizontal. Now we're going to go ahead and swing this around, and this is holding that nice and tight. And I'm a rawhide mallet here. I'm going to heat that, but I don't want to heat it into where it tightens a little bit too much. Pretty good right there. Okay, we got our 2.5 inch there, and we're down, we're level. Alright, I'm going to grab the torch, and we're just going to heat and relax this right here, and we should be able to let it cool down, and it should stay in this position here, and then we'll take our depth and we'll have a cutoff here. And then we can grab our other piece of material and create the round eyes that need to be made for this. a nice uniform glow around that loop right there, and we'll let that cool down till it's room temperature, and we should be able to pop this out, and it should be staying real close to that 2.5 inch inside diameter. I am measuring like 2 7/16 or slightly tight on that, but we can pull or fudge on that. But the uniform bend or shape, it looks pretty good in there. It's not going to be too far off from a nice uniform radius there. Maybe just a little tiny tight on the pull end here, but if we're going to take any out, we can take it out on that side there. Alright, we'll grab our material and start creating the eyes that we want to weld on here that make it look like we've bent the ring around the eye and then welded it back together. We're just going to manufacture those eyes, so we're not going to have to do all of that heating and bending and forging, which I don't have all the equipment to do that or the skill behind that, and I'm just going to make something else that looks like that's how it was made. That's a good sign, nice and relaxed there. Alright, what do we have here? A real tight 2.5. Right up close to here, like 2.5. That is pretty close D-ring, I would say. Now we're going to be 3 inches out here before this makes a cross here. And we got to create those 2 round diameters that a straight pin will go through and pivot on the knocker. Alright, let's go over to the lathe and we'll start making those 2 round trunnions, which will be duplicate this round diameter being bent, shaped around, and then welded back to itself again to create the pivot. Now, I could do that in a vise. I'm not saying that I'd be able not to do this, but I'm going to do it in another way to show you that you can create the form or the shape by machining and then add it to this by heliarc welding, or I should say TIG welding. I say heliarc a lot only because I started TIG when I was doing aluminum propellers and we were using helium with it all the time, and mixing helium in with your argon is considered heliarc, and I'm used to that, calling it that, and that's why I spit out with that terminology. Alright. Alright, this is a piece of 1.25 inch stainless steel, and we need to work with a diameter because we're working, the rod is 3/8, so if this was made to be a bent piece to go around there and we want a 3/8 hole going through the center, you would have 3 times the 3/8, which is 1 and an inch and an eighth, 1 1/8. And we got this out far enough. It's only going to be 3/8 wide plus a parting, so that's a half, 2 halves, an inch. So we're more than enough sticking out here. All right, so we're going to go ahead and you'll see me go around and tighten all 3 of these. This is a real old chuck and it's got a lot of wear on it, and I just like to lightly cinch each one. And also too, I have a sprained shoulder, and I'm kind of trying to take it easy, and I want to go around and just make sure that I have equal tension on all 3 of those, even though they control the same scroll. Alright. Across by hand. I'm not really worried. I mean, this does give a pretty nice finish, and the inserts that I'm using are pretty fast moving. So I got a flat base across there. Now I'm going to go ahead and take this diameter down, and of course it's just going to be a bent piece of stainless 3/8 rod, or appear to be, and we know that this is 1.25 inches. So we're just going to come right in. We're going to touch, set 0, and we're going to take 62.5 thousandths, which is half of the 1/8 inch, off of this diameter. A little bit of run out in that, so we just kind of guess about how much that is. We have better than 1 inch in length there, and this is 1 inch 1/17. So we're a little bit less than the 1 1/8 by a few thousandths per side. And now what we're going to do, we're going to put our 3/8 hole down through the center. We'll bring in our tailstock. I'm going to change out to a drill chuck. Alright, we're going ahead and putting in a 3/8 diameter starter drill here. Alright, now we're going to change it out for a full length jobber standard drill. Alright, standard jobber length 3/8 drill bit. Got a little bit over 1 inch on depth there, so I think we're good to go. Inside and outside about that same depth there. Now we got to create a radius on the outside that's going to duplicate the round stock of 3/8, and we're going to need to create the radius on the inside. Now we're going to start off and we're going to create the inside one after we part these off, and the reason why we're going to part them off first is because then we can have the diameter of this outside to hold square and put it square to the face of the chuck, and we'll create that inside radius with a radius tool for milling a radius, and it has a built-in radius shape already in it. We'll be able to run it right in the drill chuck. We'll go in and we'll poke it right in there and create the radius right here in the lathe.